So we've got around 15 minutes, about 20 minutes to finish some items. Explain about the IP, understanding principles used to guide and blah, blah, blah. Okay, we're going to start from define the basic role of the network layer in data network. So you are sending some information. Okay, is that right? We're going to talk and work on the network layer. Here is in OSI, but somehow it's the same. So, as you can remember, the application, presentation, and session layer is the same as application layer in TCP. The transport session is the same.
Yes.
Network session is the same. And data link and physical is the same as physical access things. Data access in the OSI, TCP protocol. Can you remember that? So, our devices use the transport layer to connect processes. Okay? At the network layer, enable device to reach each other. So, when you're going to add another item, it means that you're going to find another approach, the other facilities for just understanding how to connect something. I just give you some summary information about the IP address, default gateway, DNS thing, because I'm going to work with IP address. I just want to make sure that you know IP address is the same as your phone number, and the domain name, like bth.se, is the name in your phone book, and DNS is then, for example, you're choosing someone's name, and the mobile is calling not just the name, it's calling the number. So that's DNS. So we've got an IP address, we've got the names. Clear? So, and as you can see in here, we are using different routers for connecting to the thing, okay? Any problem? So identify the basic characteristic and the rule of the IPv4 protocol. So we've got packets here. We've got a packet with the IP header and the segment in here, okay? Okay? This is TCP segment encapsulation into IP packets. Okay, so we encapsulate it. Okay? And here we've got data layers who wants to just do his own task for these kinds of items. IP packets follow through the internetworks. So first of all, for connectionless, no connection is established before sending data packets. In here. Connectionless, no connection is established before sending data packets. It means that if I've got two computers, this is just an example, okay, for connectionless. I've got two computers here, okay? This is a connectionless communication, because if there isn't anything to send, there is no connection between them. I can say that they are idle. Okay? Yeah. Unless that there is some kind of sending packets. So here says that for connectionless, no connection is established before sending data packets. So there are items that are working separately, there isn't anything between them. That's the meaning of connection. Best effort, unreliable. No overhead is used to guarantee packet delivery. What does it mean? We don't have that much overhead for guaranteeing any packets. We are using the acknowledgement. If we're talking about in TCP, we are using a little acknowledgement. It will take some time, but it's not that much heavy. You just say that, did you receive the file? Yes. I'm going to send the file again. Okay, send it, and there's a file. Did you receive the file? Yes. I don't know. I'm going to send again. Okay, send another one. So it's not that big, but there are some acknowledgement. But as you know, in the UDP, there isn't any acknowledgement or anything like that. They just put the information on the line and send it. Media independence. Operate independently of the medium can go today. So you know that all of them are independent. They are not connected to each other in each one layer, things like that. You're going to send a letter to the post office, and some machine is in charge of connecting the post box thing to, I don't know, the destination. So that's meaning of connectionless communication. There isn't any communication unless if you've got some kind of sending information. The post office won't go to your house and won't come to your house unless you've got something to deliver or I don't know, things like that. So the sender doesn't know if the receiver is present, to send a file. If the letter arrives, if the receiver can read the letter, you just send the file. And the receiver also doesn't know when it is coming. If he knows that, he's just waiting for the mail. That's all.
So you see a little bit, you can read them. You can read them.
Okay, at the network layer protocol, describe how to use the IP protocol. You know, we've got IP protocols here, and we've got different places to route, and we've got some IP protocols again in here. It doesn't really matter how you want to send the information. It is the IP protocol, so you know the way, you can find a way, and things like that. How, we're not going to talk about how, we'll just give you some view. So, we've got the IP packet in each part. We're going to send some items from here to the other place. So, the packets are routed through the network quickly. So, the router will find the quickest way. Maybe the quickest way is like this, maybe it's like this, maybe it's like this. It really depends on the traffic of each line. Okay? So the router is in charge of finding the things. And some packets may be lost in route. So as you know, in UDP we've got these kinds of problems. As an unreliable network layer protocol, IP doesn't guarantee that all send packets will be received. You know that? And here is other protocol managed to process tracking packets and ensure their delivery. So just some review. It just goes closer and closer to the meaning of IP, but it's really, I don't really like these kinds of slides because they are much more complex than the subject.
The main subject.
Yeah. Describe the implication for the use of the IP as it's mainly independent. You know, we've got the Ethernet cable in here, we've got a node, we've got some IP packets. We're using some kind of modeling platform, the OSI. So we've got a copper Ethernet here, we've got a copper serial to this router, we've got optical fiber, we've got copper Ethernet, we've got the wireless and things like that. This is media independence. It doesn't really matter how to send the files, it just proceeds. It doesn't really matter if you're going to use the copper Ethernet, fiber optic, wireless items or copper serial or anything like that. It's just sending the information for you.
Component one is also the cable.
So IP packets can travel over different media. describe the role of framing in the transport layer and explain that segments are encapsulated as packets. So this is generating IP packets. How? Transport layer encapsulation. We've got segment header and we've got data on some file. Can you remember the segment layer? In the network layer encapsulation,